Finally, let's make some concluding remark on the visitor design pattern. For this second last slide, it simply summarizes about when you should use visitor pattern and when should you not use visitor pattern. Instead of reading off the slides, I'm just going to illustrate to you visually. That hopefully will help you better on learning that. Okay, so let's talk about two different scenarios whenever you want to judge to see how your systems are doing, or for your design is doing. You really want to think about potential changes and see how your current design reacts to those changes. That's really crucial. Remember, for the architecture of the visitor design pattern, we got the structure on the one side, we got the operation on the other side. Let's talk about the first kind of change and see how our design is reacting to it. Let's see, what if a new language construct is added? So that means we are really changing this particular part, right? So if you're really changing this particular part, let me just use maybe pink over here. Okay, so let's say, for example, if I want to add a multiplication. So what I need to do is I need to add a new clause over here, maybe call that multiplication. Okay, I'll say multiplication, and then it should be effective, and then it should be using multiple inheritance. So far, it's a single change I'm trying to make. So I'm just adding a single clause for adding the new construct. So number one, it's a single clause to be added to the structure. So when I say structure, I really meant the structure, the cluster over here. Is that the only change we have to make? Apparently not, because remember we said before the correlation that we talked about previously, right? Every visit over here should really correspond to an effective clause that's here. And this visit corresponds to the addition here, but we don't have any visit that's corresponding to this new clause over here. So that means in the visitor side, what we have to do accordingly is we have to say over here, visit multiplication, and then it's going to be maybe n is going to be of type multiplication. All right, so that's about the defer feature we have to declare at a visitor class level. Is that it? Not really, because so now every effective descendant classes over here, every one of them, we will have to implement the visit multiplication. So now that means over here I have to say visit multiplication, and then of course n multiplication. Let me just write it properly. N multiplication. Not the only place. Also need to do that for pretty printing. So when you actually got a multiplication objects at the runtime, you might either visit that for evaluation. You might visit that for pretty printing. So visit multiplication, and also m of type multiplication. Also, you might visit that dynamically for type checking. So that will be visit multiplication and of type multiplication. And each one of them should be concrete or should be effective, right? So you can see the consequence of adding a change to the structure part over here. Is that satisfying or violating the single choice principle? It's very easy to judge. Was there only a single place that you had to make the change? Apparently not. You have to not only this class over here, but also 1, 2, 3, 4. In theory, how many places do you have to add? It's gonna be an order of the number of operation classes. 1, 2, and 3 in this case. Let's say if we got 10 or 100 or n different operation classes, in that case, you need to make n changes depending on how many operation classes you have, right? So that's definitely multiple places you have to change. So definitely violates the single choice principle. So number 2, multiple places to modify in operations. Okay, so when I say operations, I really meant, so let me say operation here, I really meant this particular cluster over here, right? Okay, so now we know that whenever you want to add a new language construct over here, is going to violate single choice principle. Single choice principle. So consequently, so now if the visitor pattern is going to be adapted like the architecture shows, what should be closed? Well, apparently now you know the answer, right? Because we really want to avoid making any change like this in the structure part, right? So structure part should be closed. What should be closed? The structure, right? All right, so that's really the structure, which is the expression and language part. That should be closed. You shouldn't really add any new language construct. You want to think about when you're trying to develop the visitor pattern for your particular application, the language part should be quite stable. You want to include as much as possible, as complete as possible in the first place. You should really avoid adding new constructs into the language. The language structure should really remain rather stable. It should be quite rare that you want to add changes to it because it's going to violate single choice principle, as what I just demonstrated. Second scenario, what if we want to add, let's say, a new language operation? Well, for example, let's say we want to add code generation operation for the language, right? Maybe you want to say from the arithmetic expression, you want to generate assembly code for that, for optimization purpose. So now, what if a new language operation is added? So first of all, we have to touch. Basically, we want to add a new operation. You can see so far we got evaluation, we got pretty printer, we got type checker. So what we want to add possibly is over here. Add a new subclass over here. Let's call that code generation. Code generation. And it's going to be effective, right? Let me write a little bit better for you so it's readable. So code generation, okay, it's effective over here. So now, instead of single place, it turns out that's the single place. Of course, once you actually do the code generation class, once it's added, you have to make sure every deferred feature that's inherited to code generation, that must be implemented. So that will be, for example, visit constants, and then C of type constant, and also visit addition. Okay, just write it for short. And also 8 of type addition. Since we are only modifying just one single class and all the changes are going to be restricted to a single class as opposed to multiple classes, right? So now there's only a single place, right? So now, first of all, we say single class added to operations cluster. To operations cluster, which means this particular cluster for sure. And number 2, all changes, namely the implementation for the visit commands or visit routines, are restricted to this single class. So now, consequently, everything is going to be every change is going to be done in a single place. It will satisfy single choice principle. Satisfied single choice principle, right? You can see the derivation process is really important. So this suggests if the visitor pattern is actually adopted like above, what should be opened? So now, so that means we don't really mind how often you're going to add the operations into the visitor pattern, because every time you do it, you're just going to have just a single point of change, right? So now that part can just be open. So it's just going to be operation. So this is why we said before, alternative number 2, if I just remind you again, if you go a few pages from before, okay, you can see over here we talk about alternative number 2. So the structure should be closed because the consequence of changing the structure is going to be violating the single choice principle. And the operation part can be open because the consequence of adding anything to the operation would not violate the single choice principle. That's why this is the alternative you have to stick to if you want to use the visitor design pattern, right? All right, let's go back here. All right, so these are the two scenarios you want to really make sure you're really convinced, and you can also reproduce yourself to really understand why this case violates single choice principle, but this case it does not. And then we can make the according conclusion that so operations should be open and also structure should be closed. So with respect to the satisfaction or violation of the single choice principle. All right, so that's about everything I would like to speak about the visitor design pattern. You should really review all the details we speak about. I would say visitor pattern. You don't see the slides being made very many, but it's actually quite tricky to really get it right when you first time learn it. So that's why I try to be thorough. Okay, for this slide, everything has been covered. You can just read the slides. I'm gonna let you do it. Okay, if you got any trouble, let me know. Finally, beyond this lecture, visitor pattern is actually a very practical pattern. In this course specifically, apart from if you find it applicable to your particular projects for the lab, you can feel free to use it. But if you don't really find the applicability, I would say beyond this lecture, you may want to consider two exercises for your own good, because visitor pattern is quite a common design pattern that will be used in the industry for OOP design patterns. So number one, to get the basics, let me just show you the two links I'm thinking about you may want to go over. So the first one here, if you click on the link, is actually a complete and thorough tutorial on the composite and visitor design patterns, just to show you how you can do it from scratch in eStudio using the language example that we talked about. So if you want to just get some hands-on experience about doing the visitor pattern, you can feel free to follow that. It's optional, but I think that will strengthen your understanding about the basics of visitor pattern. So if you have done that, the second one I would recommend, okay, over here. So this is actually a reference from a tutorial I made from a 4th year level course called the Compilers and Interpreter 4302. So in that course, the students were actually asked to use the Java language, the OOP, to implement a language compiler from scratch, right? That's their projects. And for me, I simply created a complete tutorial to show them how they can build the complete compiler for a small language. And for the language, once you, of course, you got to define your grammar. You have to generate all sorts of artifacts from the grammar. But eventually, when you do programming, a critical part of it is by using the visitor design pattern. So it's a very practical usage for the design pattern. So I would say if you are interested seeing how the visitor pattern can be used in practice, and also if you're interested in building a language compiler, I would say this tutorial might be of a huge interest to you. Okay, if you click on that, you will see there's a playlist over here. Again, I can tell you that this is outside the scope of 3311. I'm suggesting this to you because I think you might be interested in seeing some practical application of the design pattern we are teaching over here. Right? All right, so that's these are the two recommended activities for strengthening your understanding and also skills of using the visitor. All right. Try them out if you wish. If you got any problem with any one of them, get in touch with me and I'll be happy to help you.